You take a rocket to the moon. It lands. You put on your work uniform and go to work your shift at a local factory that extracts water from beneath the surface of the moon. There's also fuel plants here. Dozens of people in rovers are roaming the expanse of Earth's natural satellite. When your shift ends, you board the rocket again. It takes you back home, just like a regular bus. That's exactly what NASA is planning to do. In the first stage of this project is the Prime 1 mission. Prime stands for Polar Resources Ice Mining Experiment. The mission starts in 2022. Let's follow it step by step. A booster rocket and second stage are assembled on the launch pad. Ignition. The rocket's engines begin to burn fuel, and we go up. Soon, the rocket reaches a speed of about 24,000 miles per hour. At that speed, you could travel the distance from New York to London in just 8 minutes. Once the booster uses up all its fuel, it undocks and makes a soft landing on Earth. The second stage with the payload capsule fires its engines a couple of seconds after the first stage undocks, so the rocket continues moving up. Once it reaches orbit, the payload capsule opens. It releases the lunar lander Nova C. It's a cylindrical spacecraft, as long as a sedan and slightly wider than the height of the average person. It starts its engine and begins its journey. First, the lander makes a circle around Earth. This is a gravitational maneuver that helps it to gain speed without wasting too much fuel. Because the lunar lander is still in orbit, Earth's gravity affects it. The spacecraft looks as if it's falling, but not to the surface of our planet, along its orbital trajectory. After one lap around Earth, the lander adjusts its trajectory and heads for the moon. The distance it needs to cover is 238,600 miles. That's like 9.5 trips around Earth, or 93 trips across the United States from coast to coast. Modern spacecraft can cover this distance in as little as 9 hours. That's a bit more than a journey from New York to Los Angeles by plane. At the same time, it took the first astronauts about 72 hours to get to the moon. Soon, Nova C is near its destination. It makes another circle around the moon while it descends. Scientists have already chosen the perfect plane for it to land. There are several requirements. First of all, there should be signs that there might be ice under the surface in this location. Second, the lunar module should be able to maintain radio communication with Earth. And this is impossible if the lander is on the far side of the moon. When the first astronauts flew around Earth's natural satellite, contact with them was lost for a few minutes. The connection only resumed when their spacecraft came out of the lunar shadow. And the last requirement for the landing area is sunlight. The lander has solar panels to power its scientific equipment, onboard computers, and communication modules, so it needs direct sunlight. The lander is getting closer to the surface of the moon. The spacecraft is slowing down as it approaches the landing site. Now, it's almost hovering in midair. A few more seconds, and touchdown! The spacecraft makes a soft landing. It's time to drill through the surface. For this, the lander has a device called the regolith, an ice drill for exploring new terrain. To put it simply, it's a large, 3-foot-long drill. That's almost as long as a grown-up person's leg. Once the right spot is chosen, the device gets lowered into the lunar soil. Drilling will have several stages. Lander will have to lift the drill several times to get the soil out of the drill hole. Otherwise, it may damage the drill bit. Next, the lander will have to analyze the soil composition. To do this, it carries a mass spectrometer, observing lunar operations. Shortly, M-SOLO. Its work is based on a simple principle. It ionizes or charges particles of soil, making them move. Then it creates a strong magnetic field, which affects the charged particles, making them change their trajectory. Different substances, their molecules, and atoms move differently in the magnetic field. So, by analyzing the changes in their trajectories, we can identify the mass and charge of each particle. All we need to do next is look at Mendeleev's periodic table and see which atoms we can find in the samples. Scientists hope to find H2O, water. The south pole of the moon is an ideal place to keep ice within reach of our drill. The equator would be a great place to maintain radio contact and power the solar panels of the lander, but this area is likely to be too hot to have any ice. The lander will also carry a lunar hopper. This thing will be used to explore the surface of the moon. It will carry a load of about 2 pounds. Scientists will also test 4G communication technology. The lander should have some special modules for this. If the test is successful, people might be able to use cellular coverage for communication on the moon, like we do on Earth. But the main goal of the mission is to prove that the resources found on the moon can be used in the future. As early as 2023, NASA plans to send an autonomous rover called Viper, which stands for the Volatiles Investigating Polar Exploration Rover, to the moon. It'll land at the moon's south pole for the same reasons: the connection with Earth and sunlight. The rover itself will be about the size of a golf cart. It'll carry a drill and soil analyzer. Scientists have already laid out a route for the rover. It's about 10 to 15 miles long. It'll take Viper 100 days to travel along that route. It'll drill the soil in search of lunar ice and mark its findings on the map. It will be necessary to prepare for astronauts' arrival to the moon. It'll also help to provide them with valuable resources, like water. Later in the 20s, NASA will launch the Artemis mission. For this purpose, scientists have been constructing the Orion spacecraft for decades. It can carry 6 astronauts. The launch vehicle that will take Orion into orbit is called the Space Launch System. When ready, it'll be the most powerful rocket in human history. The first flight will be uncrewed. It's scheduled for 2022. Like the lunar lander, the spaceship will ascend into orbit, make one revolution around our planet, and go to the moon. Once it reaches the satellite, it'll stay in orbit for 6 days and then return to Earth. It'll spend a total of 25 days in outer space. The second mission is planned for September 2023. This time, we'll send 4 astronauts to the moon. They will fly around Earth's natural satellite and return without landing on the lunar surface. This will be the first crewed mission to the moon since 1972. The third mission, Artemis 3, is scheduled for the 55th anniversary of the first lunar landing in 2024. 4 astronauts will travel to the moon's orbit. Once there, 2 of them will move to the Starship HLS. This is a new lunar lander designed by SpaceX. Then they will make a soft landing on the moon's surface. The astronauts will spend several days there. Then the lander will fly back into orbit, dock with Orion, and return to Earth. There's also plans to build a space station in lunar orbit, the Lunar Orbital Platform Gateway. It'll be almost like the International Space Station. It'll be assembled from a lot of modules, just like the ISS. There will be a power and propulsion element. This is going to be the first module equipped with engines for maneuvering and propulsion. There will also be solar panels that will power the station. One more module will serve several purposes, including communication and refueling. Then, there will be several living modules. They will be able to host several astronauts for a period of up to 90 days. That's where they will eat, sleep, train, and conduct scientific experiments. The station will be equipped with a robotic arm. It'll help spacecraft dock with the station, as well as install additional scientific equipment outside the station. There will be an airlock module. Incoming spacecraft will be able to dock with the station there. It'll be like a parking lot for dropping off and picking up passengers. Astronauts will be able to use it as a door to outer space. There will be a sample return vehicle, a small spacecraft that will deliver samples of lunar soil to the station. It'll be fully robotic. The Gateway will be much smaller than the ISS. For comparison, the near-Earth station now consists of 11 modules, and its total cost is about $150 billion. In the future, we'll use this station as a launch pad to send spaceships to other planets, like Mars, or into deep space. Rockets launched from the ISS will need much less fuel, because they won't have to fight Earth's gravity. But the astronauts on the Gateway will be in more danger than on the ISS because of radiation. Earth's magnetic field acts as a shield that disperses the sun's harmful rays. And astronauts staying there don't get much more radiation than the passengers of a commercial airplane on Earth. The moon is too far from our planet's magnetic field, so all the modules of the Gateway station will have to be additionally protected from solar radiation.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the 4th planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these two cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now this theory is quite plausible. because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.
How many people do we need to create a new civilization? And not on Earth, but on Mars, and in limited conditions. And if we create this colony and send them off, what problems will they face? How can they survive that far away from home without any support? A recent scientific study sheds light on these questions, so let's take a look at it. Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the 4th most distant planet from the Sun and the 7th largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Salotti, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Salotti suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together.
Hey!
Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Salati describes two things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do, make some tools for example, and all this must be produced in sufficient quantities before the literal deadlines. Salati says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all of this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Salati tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to 2 things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties. but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in… Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in the starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub Impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you. Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time, they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us. in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called eROSITA, to look for X-rays coming from Ansky. At first, they didn't see any. Then, in February 2024, another group of scientists noticed something new: bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name: quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So, when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, Everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing. Organic molecules. The galaxy in question has a long name SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name. A polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and break the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bippo Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby! This catapult-like system on the Moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the Moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The Moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors, and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the Moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the Sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the Moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the Moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the Moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remained stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out. Frozen plains, mountains with white peaks glistening in the distant sun, and rustic red snow. Welcome to Pluto, where nothing makes sense anymore. Looking at it from a distance, the ice ball planet is mostly predictably winter shades of white and light blue. Once you land on the surface, you'll notice familiar blue skies as well. But see that whale-shaped red stain running along the equator? Right there to the left of the white heart-shaped region, there she blows. This spot is bigger than Alaska, and it's a mystery to scientists. That's not red clay soil or anything you'll see on Earth. That's Pluto's version of ice. Scientists believe it's red because the atmosphere drops this strange soot-like chemical called tholin on the surface. It's the same stuff that explains the red cap on Pluto's moon Charon. Now, let's zoom in closer on the whale. Oh look, we have a mountain range. Yes, Pluto's red ice is like rock, hard enough to form entire mountains. Those white peaks standing out against the dark red aren't snowy caps like we have on Earth. That's frozen methane. For such a small planet, Pluto's mountains are epic, bigger than Everest and made entirely of ice. Such a bizarre landscape can't be found anywhere else in our solar system. Yeah, Pluto's a pretty harsh cold place. Temperatures there can dip to minus 400 degrees Fahrenheit. The coldest ever recorded on Earth was in Antarctica, a measly minus 135. Now let's head back to the heart of Pluto. That's actually a vast plain covered in nitrogen ice. Scientists discovered that Pluto's heart makes the winds on the planet blow. Craters are also big, and some of them show signs of filling and erosion. That's something that happens right here on Earth. When land is worn away and shaped by natural forces like wind, water, and ice, that's erosion. So, what makes all this so special on Pluto? It could be evidence of tectonic plate activity. You know, big plates of land surfing on liquid rock, forming mountain chains, breaking continents apart, putting them back together. That's something scientists so far have only ever seen on Earth, not on any other planet in the solar system. Now, looks like Pluto could be more like our own planet. That, and there's water on Pluto, 1/3 of its surface in fact. But of course, it's not like Earth water. It's more like a rocky slushy. Yum. Still, no signs of life out there, at least not for now. It's taken a long time to get the little information we know about Pluto. It was first discovered almost 100 years ago and deemed the 9th planet from the Sun, until 2006 when its official planet membership card was revoked. Poor Pluto. It was dubbed the biggest dwarf planet in the Kuiper Belt, a region outside our solar system full of other dwarf planets and icy bodies circling the Sun. A few months before that, they launched the New Horizons mission. It was the first space probe researchers sent to Pluto in 2006. Zipping at over 35,000 miles per hour, that's 45 times the speed of sound, it still took the probe almost a decade to reach its destination. That's how far away the tiny planet is. In fact, Pluto is nearly 40 times the distance from Earth to the Sun. If you were there looking up at the sky, you'd see the Sun as a tiny dot like any other star in the sky. Once New Horizons finally reached Pluto in 2015, it got close enough to get some incredible pictures of the surface. It also collected important data and observations, like those strange red spots and that heart-shaped region. But Pluto gets even stranger, especially its orbit. Most other planets go around the Sun in almost perfect circles with the Sun close to the center. The Sun is nowhere near the center of Pluto's orbit, and the orbit is so stretched out that Pluto sometimes crosses into Neptune's path and gets closer to the Sun than the blue gas giant. So, the unusual effect of the strange orbit? Pluto sometimes has an atmosphere and sometimes not. When it's closer to the Sun, a thin atmosphere of nitrogen forms. But once the planet starts moving further away from our Sun, the atmosphere freezes and falls to the surface in an ice storm of epic proportions. Pluto is probably a lot smaller than you imagine. If you put it on a map of the Earth, it would only span about halfway across the US. Yet this little planet has 5 moons spinning around it. And life on Pluto would be one endless year for us humans. Imagine no birthdays your whole life. Since it was discovered in 1930, we still haven't seen it complete a full circle around the Sun. 1 year on Pluto is 248 Earth years, and we'll finally see that happen on March 23, 2178. Mark your calendar. Since Pluto got kicked out of the official Planet Club, Neptune became the last one in line. It's actually a big ball of ice and gas. So, like with the other gas giants, if you tried to land on this planet, you just keep going deeper and deeper into seemingly endless clouds and atmosphere. Funny thing about the blue planet, it might not have a rocky surface like you and I are used to, but its surface-level gravity is about the same as Earth's. Same can't be said for any other planet in the solar system. As we make our way closer to the Sun, we pass the next gas giant, Uranus, that non-conformist planet that goes around the Sun basically rolling on its side. One full orbit is 84 Earth years, so you might be lucky enough to celebrate your first birthday in your whole life there. Only one party, so you better make it count. And now we approach the jewel of the solar system, Saturn, the second biggest planet after Jupiter and another gas giant where you'd sink in an endless atmosphere if you tried to land a spaceship there. Saturn is the least dense planet of them all, meaning if you put it in a giant glass of water, it'd float. Those famous rings are made up of dust, ice, and rock. Some as tiny as a grain of sand, others bigger than houses. But get this, Saturn's rings are raining down on the planet, enough to fill an Olympic-sized pool in a half an hour. At that rate, the famous blue ring system will disappear completely in 300 million years. By the way, Neptune, Uranus, and Jupiter also have rings. They're just not as visible and bright as Saturn's. Imagine combining all the planets into one. Now make it 2 times bigger. Still not as large as Jupiter. Scientists called it a failed star, since it's mostly made of helium and hydrogen, just like our Sun. But jumbo-sized Jupiter still isn't massive enough to kickstart the chemical processes that could turn it into a star. It's the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Imagine trying to squeeze sleep, work, friends, hobbies, movies, shopping, your whole routine in less than half an Earth day. Magnificent tall mountains, the highest in the entire solar system. The most epic dust storms ever. Deep valleys, craters. I'm talking Mars, our potential home in the future. If you love sunsets, you'd definitely enjoy Martian ones. They're incredibly blue, while the sky throughout the day is pinkish red. Even though Mars is our closest neighbor, from the surface, the Sun would look half the size it does from Earth. So, not as close as it seems. Oh, and if you always dreamed of becoming a basketball player, Mars is your place. The red planet's gravity is only 37% of Earth's, so you jump 3 times higher there. Venus is a planet of extremes. The hottest surface, the most volcanoes, the brightest planet, and the closest one to Earth. It's also the slowest spinning and barely rotates, making a day on Venus last 243 Earth days. You could literally walk faster before the planet makes a complete turn. Venus also rotates in the opposite direction that Earth does, so sunrises are in the west and the sun sets in the east. Mercury. It doesn't have any moons or rings, and we're talking about the smallest planet in the whole solar system. A year lasts only 88 days, so if you live there, you'd have a lot of birthdays. Mercury is the closest planet to the Sun, but it's actually not the hottest. That prize goes to Venus. Temperatures on Mercury don't get as high as on Venus because it doesn't have an atmosphere to trap heat from the sun. What Mercury does have is wrinkles. Its iron core cooled and shrank, causing the surface to contract too, and leaving all those wrinkles. That, or because it's so close to the sun with no SPF. Maybe.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than negative 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you move this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What of you? Discovered in 2017, KELT 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet. Jupiter's moon Europa is covered in a thick layer of ice, but underneath it is a vast ocean of water, measuring up to 100 miles deep. Water ice was previously thought to be rare and only common on Earth. But it can, in fact, be found all over the solar system, even on Mercury and the Moon. Saturn is less dense than water, so if it were thrown into a giant pool, it would float. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. There are 8 confirmed planets in the solar system, but evidence shows there can be a 9th. We just haven't discovered it yet. Organic matter could have been brought to Earth by comets, since it has been found on several of them. Saturn also has a never-ending storm, just like Jupiter, but it's also peculiar for its shape. It has 6 distinct sides. Mercury and Venus are the only planets in the solar system that have no known moons. Jupiter has 79 known moons orbiting it, the largest of which is Ganymede, and it's bigger than Mercury. It was thought that the Milky Way was a belt before, but now we know it's a spiral galaxy. Footprints on the moon can't disappear because there's no wind to blow them off the surface. There's a theoretical possibility of a white hole, the reverse of a black hole. Nothing can enter it from outside, but light and matter can escape from within it. Although there are trillions of stars in space, we can only see a tiny fraction of them in the sky. Charon, Pluto's moon, is half the size of its planet, which is why Pluto orbits a bit around a spot outside its own axis. All the objects in space, including planets, interstellar dust, and whole galaxies, comprise just about 4% of the universe. The rest is dark matter and dark energy that can't be seen and isn't fully understood. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants, similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189733b, I won't say that again, is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. Plus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Kepler 70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists. But the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now, and will probably be no more in the near future. If the Sun was the size of a front door, our planet would be the size of a nickel. In other words, the Sun could fit more than 1 million Earths. Moon rocks have a super slow erosion rate. That's why the Apollo astronauts' footprints left on the moon are likely to stay there for 10 to 100 million years. Another one of Saturn's moons, Iapetus, has unique two-tone coloring. The difference between the satellite's two hemispheres is impressive. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery just yet. All the planets of the solar system would fit between Earth and the moon with some space left. Yes, there's lots of space in space. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they're thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much further away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles, so, depending on where you are, sound waves can be possible. Discovered in 2017, Kelt 9b is the hottest planet we know of. That's because Kelt 9b orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? You wouldn't? Okay. One moon day is equal to about 29 days on Earth. It takes that long for the sun to cross the lunar sky. People always see the same side of the moon. The Earth's gravitational field makes the moon spin around its axis slower. That's why it takes the moon the same time to rotate around its axis as to orbit around the Earth. It was only in 1959 that people could finally see the other side of the moon, thanks to a photo taken by the Russian spacecraft Luna 3. The other side of the moon is more mountainous than the one we see from Earth. It can be explained by the Earth's gravity, which made the crust on the visible side of the moon thinner. Craters on the moon were left by asteroids 4.1 to 3.8 billion years ago. They're still visible, only because geological changes on the moon aren't as active as on Earth. The moon's gravity is only 1/6 of that of Earth's. You would be able to walk a distance 6 times longer and carry a weight 6 times heavier there. Though it's easier to walk, it's more dangerous too. An astronaut's foot in a heavy spacesuit might sink into the moon's ground. Long-distance jumps can be uncontrolled and dangerous, as the moon's surface is full of deep craters. Because of the low gravity, lunar dust consisting of tiny hard and very sharp particles and smelling of gunpowder is all over the moon. It makes a mess, causes symptoms like hay fever, and gets into spacesuits, ruining them. It's not all bad though, since at sunset and sunrise, the dust sort of dances. It floats above the moon's surface because electromagnetic forces make the particles float up. The moon does have a kind of atmosphere which is called an exosphere. It consists of helium, neon, and argon. It's 10 trillion times less dense than on Earth.